Okay, hello again, my friends. This is classwork 8.6 on vectors, page 563, 1 through 15, 23 through 27, 33, and 35 odd. So be checking your answers in the back of the book. And again, hopefully if you take your time on the homework, understanding what all the new vocabulary and concepts, the classwork itself shouldn't take you very long because the calculations, as you'll see, are fairly simple. But if not, that's why I'm here. I'm happy. It's kind of fun. I like doing your homework with you. So let's go ahead and look at number 5. Question number 5 says the vector with an initial point m at negative 4, 5, and terminal point n at 4, negative 3. Write the vector in its component form. Okay. Now you don't have to graph it, and you could do this without graphing it. But I'm just going to work through it slowly. And again, notice these are not vectors. These are not vectors. They are coordinates because they're in parentheses. And so we're trying to find the one vector formed by these 2 points. So let's go ahead and start basically by drawing XY axis. You do not have to, I'll go over the quick way to do this at the end. But let's plot M, back 4. I'll go ahead and switch to red here. 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5, just fit it in there. So this is M. N is over 4, down 3, because I'm horizontal, vertical. 1, 2, 3, 4, down 1, 2, 3. So here's N. Now again, direction does matter. So it says that M was the initial point, and N is the end point, so that means it's going from M to N. So I'd want to draw it like that. Okay, M to N. And then I need to write it in its component form. Well, that's just the overall vertical and horizontal change, with horizontal coming first. So I can just use this to count that out. Again, it is important that it started at M. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. So we went across 8. So that means the first point is 8, comma, and then from there, what did we do? We went 1, 2, 3, 4, 5, 6, 7. We also went down 8. So this is a change of negative 8. Now the negative does matter. We went 8 to the right, which is positive, and 8 down, which is negative. So that's why the component form is 8, comma, negative 8. So direction matters. So know that you're starting at M, going to N. Because if it was reversed, we would have we'd be positively going up, and then a negative going back. So make sure you do go in the right direction, which is one reason why I'm reviewing this. So component form is 8, negative 8. Now, if you didn't want to draw this out, you can just go ahead and look at your numbers and find the difference. That from negative 4 to 4, I can just mentally potentially figure out that's just a change of 8. And then to go from 5 down to negative 3, I would have to go down negative 8. So you don't have to draw this, but again, visualizing it can be helpful. Okay. And again, if we wanted to, we could find the magnitude of this, which is what we'll be practicing with a different problem here. Or we could find, the direction of this, which is what we'll be doing for a different problem in 25. So let's take a look at those. 23 says, draw the vector on a coordinate plane and then find its magnitude, which is just its length to the nearest tenth. Okay. Yes, sir. So let's go ahead and draw ourselves another little XY axis here. I should label my axes. Okay. Notice I don't worry about saving paper. Some of you cramming everything into tiny spaces. Look, the trees have made the ultimate sacrifice. Honor them by using the sheets of paper. It's really nice to work big with plenty of room. So this is my horizontal change. So over 2.5, 1, 2. Again, we can find the middle spot right about there. And then down 3.5, 1, 2, 3.5. So it went down right about there. I'm going to switch because I like to graph in a different color. So over 2.5 and down 3.5 puts me right about there, right in the middle, from the origin. And again, I can write these dimensions in if it helps. This was negative 3.5. This distance was 2.5. You don't have to do that. But again, these are just A and B of a Pythagorean theorem. Sides of a right triangle, a squared plus b squared, gives me the magnitude, the hypotenuse, c squared. So I'm just going to go ahead and square 2.5 squared plus, and you can do negative 3.5 squared, but it's always going to end up positive, so you can almost ignore that when doing a problem like this. Not going to be able to pull that out of the top of my head right away. Congratulations if you can. Okay, so let's go to clear. 2.5 squared is 6.25. I'm going to work this slowly. Could go faster. 6.25 plus, let's go ahead and go 3 squared, 3.5 squared, 12.25 equals c squared. Alrighty, now go ahead and add those together, plus 6.25. Alright, that's 18.5. So 18.5 equals c squared. Just going to square root both of those and find this to the nearest tenth. Again, with calculators, it doesn't really matter. I'm not scared of decimals. Okay, so clear that out. Square root of 18, which we can see, you can do a quick estimate. 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, so it's going to be 4 point something. And yeah, there it is. Square root of 18 is 4.2. Okay. Oh wait, you know what? I didn't do 18.5. Let's see. Square root of 18. I got excited. 18.5. There we go. 4.3. So we should be getting 4.3 as our magnitude. Again, don't be thrown off by the decimals. Just do it what we know to do. A squared plus b squared gives me the hypotenuse c squared, which in this case is the magnitude of that vector. And the other thing we do with vectors is find directions. Now 25, it's a different problem. It's interesting, the numbers are very similar. They want you to not be afraid of decimals, I guess. And so it says, again, find for 25, draw the vector in the coordinate plane, so we do need to draw it. Find the direction of the vector to the nearest degree. Okay, sure thing. Yes, sir. Why not? Math is fun. Okay. So, over 3.5 this time. 1, 2, 3.5. Up 2.5. 1, 2.5. So we're going to be right about there. Switching to red. If you didn't know, Albert Einstein was a very unmotivated student until he picked up a geometry book. Changed his life, changed the world forever. So this could happen to you, even during quarantine. Okay, so there's our vector, which, just on a side note, notice because the dimensions are the same, notice it's in a different direction as our previous problem, but the magnitude, because the sides are still 2.5 and 3.5, I already know the magnitude of this would be 4.3, so fun fact. But that's why it's important to know both magnitude and direction, as they say in Despicable Me. So we got to find the direction, and I can either find this angle from horizontal or this angle from vertical. It really is just whatever makes you happy. I'm going to stick with the horizontal here. So I'm going to imagine my triangle like this. So that means my opposite from here was 1, 2.5. And my adjacent was 1, 2, 3.5. Because I want that order will make a slight difference. 2.5 over 3.5, or which one you put on top matters. So be careful. All right, so that's why, again, I draw things out to be clear in my mind. So if this is my angle, then my tangent of my theta equals the opposite, 2.5, over the adjacent, 3.5. And again, decimals, I just don't care. Ain't no thing like a chicken wing. So we're just going to inverse tangent both of those, and we'll find out what my beautiful angle is. Okay, so clear that out. Switch over to inverse tangent of 2.5 divided by 3.5 equals Checking. This is a live demonstration. Yes, we're going to round to the nearest whole degree. So that is 36 degrees. Approximately 36 degrees. Now I got to give my dimensions, my compass directions in order to be finished. I know the book doesn't have that, but you know, you're smarter than the book. Again, started from the east, 36 degrees, and I shifted 36 degrees north. So east, 36 degrees north, heading of that submarine. It's an enemy submarine, so let's go destroy it. Okay. So again, using two coordinates to find the component form, finding magnitude, finding direction, and you are off and running. Please reach out if you need any help. Also, this is our last lesson before Easter, so happy Easter. Jesus is risen, and if you put your trust in him, you're on your way to heaven. And learning math is just something we get to do as we enjoy the ride along the way.